Hello, I am Ahmad, and in this video, I'm going to talk about a second order differential equation or linear. We will cover the homogeneous and non-homogeneous second order equations. The irony is that usually we learn the differential equations in a separate course, and at that time, perhaps we do not know about what we're going to do in the future with those solutions. But as far as I have some videos about the buckling and stability calculation and other stuff, I want to link that part to this differential equation solution. So we are not covering everything in differential equation, only the second order equations with the constant numbers are covered. Also, homogeneous and non-homogeneous equations are covered in this video. Let's see. Second order differential equation is usually given as fx, second order derivative of a function like y, plus gx, first derivative, plus hx times y, equals to a function like ix. This is the general form of the second order equation. In the linear equation, instead of fx, gx, and hx, we have the constant numbers like ay second plus by prime plus cy equals to a function like ix. If ix is going to be 0, then the equation is called homogeneous equation, or it is called characteristic equation. So it means that we have a second derivative of y plus by prime plus c equals to 0. If ix is not 0 and is a function of x, then it is called non-homogeneous equation. Now we are going to cover these two latest part. We are not going to cover the general form, and for ix also I will cover only one condition, just the polynomial, not covering all the things that might be needed in the differential equations course. So first of all, solution of homogeneous equation. First, we need to form the characteristic equation. Instead of y, we can use r or other parameters, and when it is second derivative, we go with r power by 2. When it's the first one, we go with r, and when it's only y, we put as 1. So here I made a, so this should be cy equals to 0. So then it will be a r2 plus br plus c equals to 0, and then we will have r1 and r2 as the solution of these two second order polynomial. There are three options. R1 differs from R2, and they are real values, not complex values. So in this case, the homogeneous solution will be C1 e power by R1t plus C2 e R2t. The other option would be R1 is as same as R2. So it means that delta of the equation, which is given by this b square minus 4 times ac is 0. So in other words, I can write down that delta is 0 in this case. And homogeneous answer will be C1 e power by RT plus C2T e power by RT, assuming that R1 and R2 are the same. The other option is if R1 is alpha plus I beta and R2 is alpha minus I beta. It means that delta is negative, I is referred to square root of minus 1. So in this case, homogeneous answer will be e power by alpha t times C1 sinus beta t plus C2 cosinus beta t. Let's have some simple example. So assume that we have second derivative of y minus 2y prime minus 3 equals to 0. First, we need to form the characteristic equation, which is r2 minus 2r minus 3 equals to 0. And then delta will be minus 2 power by 2 minus 4 times 1 times minus 3 will be 4 plus 12, which is 16. So as a result, r will be 2 plus minus 16 square root divided by 2. So 2 plus 4, 6 divided by 2, 3, and 2 minus 4 minus 2, so it will be minus 1. And now we see that R1 is 3, R2 is minus 1. So as a result, homogeneous answer will be C1 e power by 3t plus C2 e power by minus t. Very simple. Now let's go to another example. Second derivative of y plus 2y prime plus 1 equals to 0. So in this case, the characteristic equation will be r2 plus 2r plus 1 equals to 0. Delta is 2 power by 2 minus 4 times 1 times 1 and is 0. As a result, r will be minus 2 plus minus 0 divided by 2 and it will be minus 1. For sure, we can go with a r plus 1 equals power by 2 equals to 0. As a result, r1 equals r2 equals to minus 1. So in this case, the homogeneous solution will be C1 e power by minus t plus C2t e power by minus t. The next example would be second derivative of y plus 2y prime plus 2y equals to 0. Characteristic equation r2 plus 2r plus 2 equals to 0. And delta will be 2 power by 2 minus 4 times 1 times 2 will be minus 4. And then r will be minus 2 plus minus square root of 4 divided by 2. So r will be minus 2 plus minus 2 square root of minus 1 divided by 2 will be minus 1 plus minus square root of minus 1, which is I. So it will be minus 1 plus minus I. In this case, alpha is the real and beta is the imaginary part. So alpha is minus 1 and beta is 1. Plus minus is not counted, so always beta is a positive number. So homogeneous answer will be then e power by minus t times C1 sinus t plus C2 cosinus t. That's the solution of homogeneous equations. One thing that is very common in engineering is this type of equations. You have second derivative of y plus, for example, 4 times y equals 0. In this case, r2 plus 4 will be 0, and we can write down r2 is minus 4. Then r will be plus minus square root of minus 4, which is plus minus 2 square root of minus 1, and is plus minus 2i. So here we do not have any alpha. Alpha is 0, and beta is the imaginary coefficient. Homogeneous answer will be e power by 0 t times c1 sinus 2t plus c2 cosinus 2t. E power by 0 t is 0. As a result, homogeneous answer will be c1 sinus 2t plus c2 cosinus 2t. And now a very general form would be second derivative of y plus lambda 2 y equals to 0. The characteristic form will be r2 plus lambda 2 equals to 0. r2 will be minus lambda 2, and then r will be plus minus square root of minus lambda 2. As far as lambda 2 is a positive number, its square root will be lambda, so it will be plus minus lambda times square root of minus 1, or we can say plus minus I lambda. So in this case, alpha is again 0 and beta is lambda. As a result, homogeneous answer will be, usually it is written instead of C1, C2, which are constant that should be found by the boundary conditions, we call the A and B. C1 and C2 are general, A and B are also constant values that are unknown. So we can go with A sinus lambda t plus B cosinus lambda t. Now the next phase is to calculate for the non-homogeneous equations. But still we are in the linear condition. So it's not going to be with the functions of x or t, for example. So it is usually given as a second derivative of y plus by prime plus c equals to fx or ix. Let me write with the ix that I used in the first statement. So ix can be sinus, cosinus, but in this video I'm going to solve this only for the polynomial. Let's say ix is a polynomial like a0 plus a1 x1 plus a2 x2 plus 𝑎𝑛 xn. So in this case, what do we need to do? First of all, solve the homogeneous form of the equation. Find particular solution relevant to ix. 3. So this is called y homogeneous and this is y particular. The solution will be homogeneous solution plus particular solution. The only thing is how to find ix, a particular solution. For that, if ix is a polynomial, then the solution can be given as x powered by s times, now we are looking for a0 plus a1x1 plus a2x2 and so on. So the only thing that we need to find is S. S is the number of zero solution for characteristic equation. For example, it can be, in this case, as far as we are dealing with the second order, S can be 0, 1, and 2. Because the maximum number that R can be 0 is 2, and the minimum is 0. Now, we can have a simple example. So, second derivative of y minus 2y prime minus 3y equals to t power by 2. So it can be x power by 2. So it shows that y is a function of t or y is a function of x. In this example, y is a function of t. So first we need to form the characteristic equation. It will be second derivative of y minus 2y prime minus 3y equals to 0 in homogeneous format, and then we write characteristic equation r2 minus 2r minus 3 equals to 0. I can write this down. R equals to 2 plus minus square root of 4 plus 12 divided by 2, so it will be 2 plus 4 divided by 2, 3, 2 minus 4 minus 1. So then homogeneous answer will be C1 e power by 3t plus C2 e power by minus t. Now, how many times 0 is the root of characteristic equation? This is the question that we need to ask. How many times r equals 0, or let's say 0 is the root of characteristic equation? Here we can see that r1 is 3, r2 is minus 1, so no, there is no 0 in the roots, so no 0. As a result, S will be 0. Now we can form particular solution. It is t power by s. It's a t power by 2, so I have to write a polynomial with second order. Instead of a1, a2, a3, or a0, a1, a2, I use a, b, and c. So it will be a t power by 2 plus bt plus c, of which s is 0. So it will be a t power by 2 plus bt plus c. Now I can make the first and second derivative. Y prime will be 2at plus b, and second derivative will be 2a. We need to substitute these y prime and second derivative to the main equation that we had in the question. So it will be 2a minus 2 times 2at plus b minus 3 times at square plus bt plus c. Should be the same as t. 2a minus 4at minus 2b minus 3at2 minus 3bt minus 3c equals to t power by. Now I can write it in a descending way, so it will be minus 3at square, then minus 4a minus 3b t, and then 2a minus 2b minus 3c equals to t squared. Now, 3a should be minus 3a should be 1. Minus 4a minus 3b should be, there is nothing for 0, for t should be 0. And two a minus 2b minus 3c should be 0. From the first one, I can calculate a, which is minus 1 over 3. From the second one, I can write down 3b will be minus 4a, will be 4 over 3. As a result, b will be 4/9. And here 2 minus 1 over 3 minus 2, 4 over 9 will be 3c. And then I can write down minus 2 over 3 minus 8 over 9 will be 3c. As a result, minus 6 minus 8, 14. C will be minus 14 divided by 27. Now I can write the particular solution. It will be minus 1 over 3t squared plus 4 over 9t minus 14 over 27. Usually I cross-check after my solution. You can do the same. So minus 2 over 3t plus 4 over 9. And this will be minus 2 over 3. And the equation was I can bring it to next page. Minus 2 over 3 minus 2/3 minus 2 times minus 2/3 t plus 4/9. I can just, or let me write it down. Plus 4 over 3t minus 8 over 9 plus t2 minus 4 over 3t plus 14 over 9. So 4 over 3 by 4 over 3 gone. Now these 3 minus 6 minus 8 plus 14, so it's 0. Then T2 is the answer. So we can see that, okay, we solved luckily correct. Now the solution will be homogeneous answer plus particular answer. C1e 3t plus C2e minus t and plus or minus 1 over 3t squared plus 4/9t minus 14 over 27. That is the solution for non-homogeneous equations. Now let's go through one typical example which is relevant to stability. For example, a second derivative of y plus lambda 2 y equals to constant x. C is a constant. Instead of C, better to write K. So first we need to solve the homogeneous form. Second derivative of y plus lambda 2 y equals to 0, and we solved it earlier. Homogeneous solution will be a sinus lambda x plus b cosinus lambda x. And there is no 0 for the roots. As a result, s will be 0. Particular solution will be x powered by s, which is 0, times, now it's the first order, then it will be c1x plus c2. So particular solution is c1x plus c2. The first derivative will be c1 and second derivative will be 0. So if the solution is kx, then the second derivative will be always 0. We do not have y prime in the main equation. As a result, the only thing will be lambda 2 times y. And it will be lambda 2 times c1x plus c2 equals to kx. So it will be c1x plus c2 will be k divided by lambda 2x. And you can see that as far as there is only x in the other side of the equation, c2 will be 0 and c1 will be k divided by lambda 2x. Particular solution will be k divided by lambda 2x. So from now, if you see the equation like second derivative of y plus lambda 2y equals kx, you can easily write down directly the solution. Y will be a sinus lambda x plus b cosinus lambda x plus k divided by lambda 2x. If you are interested in more, for example, if s is not 0, I can solve another example. Just in case, second derivative of y plus 4y prime equals to, let's say, x2 plus x. So in this case, r2 plus 4r will be 0. Then you will have r equals to 0 and r equals to minus 4. As a result, homogeneous solution will be c1e powered by 0x plus c2e powered by minus 4x, which will be c1 plus c2e minus 4x. And here, 0 is the root of the characteristic equation only once. So as far as r equals to 0 is one solution or one root, then s will be 1. When you want to write the particular solution, it will be x powered by s times ax2 plus bx plus c. It will be ax3 plus bx2 plus cx. Now, first derivative will be 3ax2 plus 2bx plus c, and the second one will be 6ax plus 2b. I can substitute these in equation number 1. 6ax plus 2b plus 4 times 3ax2 plus 2bx plus c equals to x2 plus x. So it will be 6ax plus 2b plus 12ax2 plus 8bx plus 4c equals to x2 plus x. I will write it down in the descending format by respect of x. 6a plus 8b x plus 2b plus 4c. And it will be x2 plus x. So 12a will be 1. As a result, a will be 1 over 12. 6, 8 plus 8b will be 1. So it will be 1 over 2 plus 8b equals to 1. 8b equals to 1 over 2, and b is 1 over 16. And then 2b plus 4c will be 0. We do not have any constant in the other side. So then c will be minus b divided by 2, will be minus 1 over 32. Now we can write particular solution, which is 1 over 12 x power by 3 plus 1 over 16 x power by 2 minus 1 over 32 x. Now it is better if we cross check. Y prime will be 1 over 4 x2 plus 1 over 8x minus 1 over 32, and second derivative will be 1 over 2x plus 1 over 8. Now we can substitute these in the main equation that we had. 1 over 2x plus 1 over 8 plus 4 times 1 over 4x2 plus 1 over 8x minus 1 over 32 equals to 1 over 2x plus 1 over 8 plus x2 plus 1 over 2x minus 1 over 8. These are gone. 1 over 2x plus 1 over 2x will be x. So the answer will be x2 plus x, which is the same as the answer. So now we have homogeneous answer and particular answer. We can write down the total solution. C1 plus C2e power by minus 4x plus 1 over 12 x power by 3 1 over 16 x2 minus 1 over 32x. This is the solution, and then you can apply the boundary conditions to calculate the constant unknown values C1 and C. Yes, it was the end of this video. We went through the solution of linear second order differential equations, homogeneous and non-homogeneous, but we didn't cover the whole thing. We just talked about the particular answer of Ix, which is mainly a case in the stability. So I hope you enjoyed, and see you in the next video. Thank you. Bye.